All right, the last case is the ambiguous case, and we're first going to start again by identifying what's given in the triangle, because you don't know when you start the question that this is the ambiguous case. So we're given a matching pair, our angle with corresponding side, and then we have another length. Remember, I like to say this is our opposite and this is our adjacent, and that's relative to the angle that's given. Now, the first assessment is the fact that this is an ASS triangle. The second assessment is that our opposite length is shorter than our adjacent length. So therefore, I am now in the situation where I either have no solution or two solutions. No solution means that this length of 9 is not long enough to reach this side of y. The two solutions means that it is long enough and it's going to create a triangle and with an angle z. But if it creates one triangle, therefore it must create two triangles. The reason why is because the opposite length is shorter than the adjacent length. So here we go. Again, we see ASS. We look and see that opposite is less than adjacent. So now it's either going to be no solution or two solutions. It's not possible to be one solution. Then we're going to start solving. What can we solve for? We have a matching pair at x. We need angle z. So sine z over z equals sine x over x. We plug in what we know. So z has a length of 15, 28 degrees, and 9. We multiply both sides by 15, and then we take the inverse sine of both sides to get z by itself. When we do that, we get an angle of, what do we get? An angle of 51 degrees. Now, because we have an angle of 51 degrees, that means that we now know it's going to be two solutions. Some of you may be wondering why it can't be one solution. Remember, with one solution, it's because our opposite length is longer than our adjacent length, and that is not the situation we're looking at right now. So let's go back to our problem. So we have our triangle. We found that we have 51 degrees. Now we can find our angle y. That's 180 minus 51 minus 28. And we get 101 degrees, so that's 101. And then we can find our length of y. Y over sine 101 is equal to 9 over sine 28. We multiply both sides. So we have 9 sine 101 over sine 28, and that gives us a length of 18.8. So our first triangle is completed. We have 51 degrees, we have 101 up here, and we have 18.8, all angles and all sides. But now we have to find our second triangle. So this is the information that we started with, the 28 degrees, the 9, the 15. We determined that we could find the angle z, and that was 51 degrees. Now, what we want to do is angle y was never given to us. We found it based on the 51 degrees. So that means that this angle could be wide enough to create that 51 degrees. But we can also call this our pivot angle. And our pivot angle means that to create that second triangle, we are going to change this angle to be a smaller angle. And it looks like this. So we've just rotated that length of 9 to the left, so towards the given angle. And the length of 9 does not change, but what's happened is it went from Z being 51 degrees to rotating around, and now it's created a second triangle. And that second triangle is where Z is now obtuse. So our first angle of Z is always acute, being between 0 and 90 degrees. And the second one, as you can see from the visual, it's an obtuse angle, so it has to be greater than 90 degrees. Now, what you need to recognize are the things that have not changed. That 28 degrees has not changed because the question has not changed. The opposite length has not changed. It's just in a different position. And that 15 has not changed. So we're still given the ASS situation. Now, the question is, how do we find this obtuse angle? Well, we're going to use some skills from geometry. If we think of that first case, triangle, it's right here. That's a 9. Well, we're taking that 9 and we're swinging it to the left. So if this is 51 degrees, if I'm looking just at this triangle, and I'm going to highlight this on the right-hand side, I really have a triangle that's created with two lengths that are the same, 9. Well, if those two lengths that are the same, that means that right here we have 51 degrees. Now that's not angle Z. Angle Z is here. So angle Z is always found by taking 180 degrees, because we have a straight line here, and subtracting the original angle of Z. So we have 180 minus 51. And that's going to give us our obtuse angle of 129 degrees. So I erased that highlighting because I wanted to emphasize the fact that the real triangle that we're solving for is this one, not the larger one. That larger one we use to find the obtuse angle of Z. So we know now that for our second case, our obtuse angle is 129 degrees. So our new angle of Y is 180 minus the original 28 degrees minus the 129 from the new Z. So we end up getting 23 degrees. Now that we have that, we can find our length of Y. Y over sine Y, and this is all for the second case, for when Z is obtuse. And X over sine X. We sub in what we know. Cross multiply, and we end up getting Y to be a length of 7.5 approximately.